Capacity of a logistic growth model. It's going to be a simple number when you actually see it, but just to give you the idea of what a logistic growth model does for us. Um, Go ahead and graph in Desmos. You'll find that you don't need to graph it once you're trying to solve. Okay. Then if you keep backing up, it looks like it's just going to go on forever. But then all of a sudden it flattens out and it never gets higher than this point right here. Okay, that's because 45,000 is the highest point. We can use logistic growth models to model like population growth because at some point the population gets to a high enough place where it's starting to compete with the members of the population are competing with each other for resources. So 45,000 is the cap of this population. Okay, that's its carrying capacity. Okay, and then you can get that from the bottom. If you think about each term, okay, e to the negative 0.8x power. As x gets bigger, this number keeps getting smaller and smaller. So if you multiply 6 by a really small decimal, it gets close to 0. 1 plus 0 is going to make 1. So the biggest number you can get out of this function is 45,000. Actually, you never reach it. You get infinitely close to it. Okay, an initial value uh, just wants you to plug in 0 because time is usually the variable for this function. Okay, so when you're talking about logistic growth, usually 0 is the starting amount. Now negative 0.402 times 0 is just 0 here, right? So we got 800 divided by 20, which gives us, made too many videos today. Okay, let's see if there's anything else. Carrying capacity, which we talked about. I think